Let's start battery pack protection. What we have done is how to sense the voltage, current, thermistor reading and all the things. So, now let's move to how to protect the pack. BMS electronics and softwares are integral part of overall risk management. When I say overall risk management, all types of protection and safety. What are the undesirable events or condition where we have to utilize the protection scheme? And those are in excessive current drawn, either during charging or during the discharging. When I say excessive current drawn, that means we also feed back the current during the charging and then take out the current or basically energy during the discharge. And in that case, we keep on measuring the current. In any case, current reaches its threshold, we should cut off the battery pack. In case of short circuit, what happens? Huge amount of current flows. Yes, it's internal, but still you can sense by using either voltage sensors, or if this is an internal short circuit, then it's difficult to detect. However, if there is any region because externally because of that short circuit is happening, that we can detect easily by measuring the current. Internal short circuit, we have to provide a lot of algorithm or provide the sensors everywhere. That's difficult, but using, let's suppose if voltage is dropping suddenly, that could be one of the internal short circuit could be one of the reason for that one. So, in such cases, we have to isolate, disconnect our pack from the external world. In case of over voltage or under voltage, if it is over voltage, that's a safety hazard. If it is under voltage, it's not safety hazard, but would reduce my pack life drastically. So, in such cases, we need to disconnect. In case of loss of isolation, and generally that happens with the high voltage packs. In case of abuse, if somebody is trying to draw more current than required, somebody is trying to put a charger of much more voltage in your system for the charging. If somebody is trying to put a system which is not compatible to your battery, those all are abuse conditions. Somebody is trying to accelerate again and again. Peak currents are for a particular time duration, but use it for his advantage. He'll accelerate and deaccelerate, accelerate and deaccelerate. So that is also abuse. In such cases, pack should isolate or disconnect itself. And how it is being done? Either you can have a cell protection ICs where you don't have a BMS, and that's what we say protection circuits, cell protection circuit. So it will disconnect the cell which is getting affected. Or when you have a BMS, in that case, since all those are being measured using the multiple sensors, the controller or microprocessor takes action and disconnect it by sending the signal to contactors or relays to disconnect it from outside world. Other protection devices what we use inside that, which does not depend upon microprocessor. At the cell level it can be at the pack level. It is like thermal fuses. As soon as you try to draw excess current, it will get heated up and will disconnect. These all are, I am talking about cell level, and if it is a pack level, then the BMS. Then it could have a small fuse also inbuilt at the cell level and the big fuse at pack level, that will blow away. Electronic fault detection, something like IMD at the pack level, and these all things comes together and forms a robust pack. So while designing, when you are selecting a cell, you can think of what are the protection available at the cell level. Does it have any electronic protection? Does it have any mechanical protection in case of anything? And that would be a secondary level of protection for you other than the BMS of a whole pack. Battery pack interfacing, with what are the things its interface? And when I say interface, it's mostly communication. So, effective communication with the interfaces is important to take a proper decision by BMS. Charging control, if it is able to communicate with the charger, if the charger is able to communicate with the battery and battery is able to communicate with the charger, whatever set limit you have put, charger will provide that much of current by raising its voltage or dropping its voltage. If the charger is non-communicating the battery, so battery whatever it sends, if it is acceptable, it will accept, otherwise it will reject. It won't allow the current to pass on that, unless it is within the acceptable limit. So, a charger, it should be capable of handling the multiple or random charges, but within the limit, not beyond the limit. What limit you have already set, functional limit you have already set. It should be able to take different rate of charging within your functional limit. It can be, if you have set the functional limit of 1 C charge, then it should be able to take 0.5 C, it should be able to take 0.7 C, it should be able to take 0.2 C, it should be able to take 0.01 C also. If the communication is happening, then depending upon the availability of the energy, like grid utilities, if it is a large pack, it would require large amount of energy, large amount of current to charge itself quickly. In such cases, if that is not available, if grid is communicating to the charger and then the battery, no, I have only this amount of energy available which you can take. The charger will set its voltage in such a way that it should be able to provide that much of current only. So, that is where the battery pack interfacing works with. So, you have real world consumer, then you have online merchant, and then the digital transfer of goods happens. So, similar way in the case of battery pack, whatever it requires, it communicates to the charger, charger communicates with the grid. So, multiple interfacing. And how does this interfacing happen? Communication mostly through CAN. Why through CAN? It is the most robust communication system utilized right now in electric vehicle, not only in electric vehicle, multiple vehicles. It has electric specification and packet controls, that is why the CAN. Then the next comes logbook function. If any abuse is happening anywhere, it should keep on recording, and then how does we know that anything happened in the way? It should communicate either through CAN, then CAN plus IoT, or keep on storing somewhere, and on demand it should be able to give us what happened in the past. Where it is stored, mostly these all the things are in the flash memory of the BMS. Communication, that is another important fact. When I say interfacing, interfacing between the system, interfacing between the subsystem, interfacing within the battery pack, interfacing with the outside world. And how come that happens? If you have a two-way communication, a real-time two-way communication or on-demand two-way communication, then only it would be able to say you what happened. So, we have a vehicle, in that vehicle we have a battery pack, and then battery pack we have a Bluetooth on the master BMS. The master BMS is communicating with the slave BMS using wired interface, either using CAN bus or Modbus. So, the common area network CAN is the most popular communication protocol being used. Other communication protocol what we use is serial peripheral interface SPI like RS485. The another thing is like I2C or I2C be said, Modbus. Those interfaces be used for communicating between subsystem, outside the system, outside the vehicle. What benefit we have using CAN? It's a simple and low cost, and that's why most preferred option. Fully centralized, extremely robust, highly efficient. In each ECU, wherever you are sending the signal or receiving signal is set as a node and connected with a CAN bus. Now, any node can send a signal and can receive a signal using the common bus. Sensing, interfacing, communication. Now, pack performance management. The BMS must communicate or report regularly its state of charge condition, because lot of controls happen based upon the SOC. And what it's a too deep inside the cell, depends upon the average particle concentration on the electrodes of a cell, but we cannot measure that. What we do, we estimate the current. We estimate using the current, Coulombic efficiency and the cell total capacity. It's estimation basically, but how good estimation is, and that depends completely upon the algorithm you are using for SOC calculation. So, it's important to use a proper algorithm and test it continuously for yourself by characterizing your cell and then battery pack. What you see on the right side is the OCV versus SOC curve, and the temperature is 25 degrees C. If temperature changes, this SOC changes, because the OCV depends upon temperature. So, you can have multiple layer or multi-dimensional table where you can store all this lab tested data and then use that for SOC estimation. What is the energy available? State of the charge is one parameter. What is the energy available in the pack? And again, that you do using the Coulomb count and the SOC and the SOH, health of the cell. And what it says, ability to do work measured in watt-hour or kilowatt-hour is the estimated function of OCV. When I say OCV, then it becomes SOC also, and then the another important parameter which comes is state of health, because capacity keeps on fading, and that is only being determined by state of the health. It's a critical input for the range of the EV, how many more kilometers it will go. When you estimate it correctly, then only you can estimate how much more kilometer your vehicle can go. Power estimates, rate at which the energy can be moved between battery to the motor or other subsystem, or from the charger to the battery. It's measured in watt or kilowatt. A 1 kilowatt hour battery pack can give you 10 kilowatt for how many minutes? For 6 minutes. But your battery is capable or not giving that is important. If my battery pack is capable of giving only 0.5 C, that means even a 1 kilowatt hour battery pack will give you only 500 watt. If my battery pack is capable of giving 10 C, it can give you 10 kilowatt for 6 minutes. And you can write down what power vehicle is consuming in the flash memory for diagnostic purpose or warranty purpose, or to find out the abuse condition. BMS records all the estimates, atypical or typical. When I say atypical, if somebody is trying to draw 10C current and your battery pack is only at 5C. So at 5C it will cut off and it will record. So I have been cut off because somebody is trying to draw more current from that. Somebody is demanding more power which is I am not capable of. So those are atypical event. Typical event, okay, he is drawing 2 kilowatt of power. That means at 2C rate. And I am capable of giving that. I am still writing that one. So a typical event you may or may not record, but a typical, atypical or critical event you must write, because that help you in multiple things like battery life estimation, if anything has gone wrong, such condition is being written in the logbook function of as a function. It also keeps on measuring number of charge or discharge cycles for warranty as well as the life, to know the life of the battery pack. This is also important for SOH calculation. Any atypical event, if any external short circuit happened, so that type of event it keeps on writing back into the logbook other than the regular parameter of interest. State of the health. When battery health is 100%, you can charge it fully and discharge it fully. Over the time, this state of the health degrades. Now, when you have, so still my SOC is 100% from here to here. So I have more range. But if my battery health is degraded to 66%, from here to here itself, now I have 100% SAC. But my overall capacity has reduced. So that's how state of health becomes important. For a user, fully charged 100% SOC, fully discharged 0% SOC. But state of health says what could be the capacity when the battery is fully functional and when the battery has degraded. It can be modeled, can be experimented, that model can be validated through experiment, and once it is validated through experiment, you can utilize that model for that particular cell. Now pre-charge circuit, any question till now? So what we have talked about? Interfacing, communication, performance management, diagnostics. Any question on this?